Hi, today is our second day on the unit circle. I'm going to call it unit circle 2 of 2. Technically in our book it's called cosines and sines in quadrants 2 through 4. So I'd start out by drawing a unit circle if I were you. I should start with this disclaimer. I'm going to beef up the section a little bit. I do more than what the book actually covers in this section, and then it makes a later section, I believe it's section 8, a lot easier to understand. So that's kind of where I'm going with this. And so we have our unit circle. And we want to start out just by labeling it up and saying, okay, right over here we'd have 0 degrees. We always start there. And positive angles are going counterclockwise around. So up at the top we have 90 degrees. And then 180 degrees. At the bottom, 270 degrees. Then back around to where we started, 0 degrees or 360 degrees, all the way around the circle. And you could continue if you did another 90 degrees plus your 360, that gets you up here to the 90 again on top, which is 450 degrees. So it's going to be a periodic function. We'll talk about that later on in the chapter as you go around. So sines and cosines, what are those going to be? Well, first thing is I'll stick with my cosine values. And we said on your unit circle, the cosine values were always the x values on the unit circle. So x equals the cosine of theta. And maybe I'll stick with green for my y. My y values are going to be the sine of theta. And so just a quick review before we actually get into the new part. So I wouldn't write this on your drawing yet, but if I were to take some angle like that. So if we look at that, we could kind of guesstimate, I don't know, maybe 70 degrees, something like that. I could grab a protractor, but so let's just make up 70 degrees. And again, I wouldn't write this part. But if we were to go through and type in cosine of 70 degrees, if my 70 is right, that should give us something right about this for an x value, or like 0.4. If you did sine of 70 degrees, we should get something about 0.9 if the angle's actually 70 degrees. Alright, but moving back then. So if we're looking at our angles, we want to first then say, well, all of our things here in this quadrant 1. So first of all, what angles is that going to be? So here in quadrant 1, we're going to have angles that start out at 0, so 1, 2, 3, 4, 5, up to 90. And maybe I'll get rid of this guy then. And I could then say up in this quadrant, so I'll maybe say 0 is less than theta is less than 90. Maybe I'll put my little degree symbols in there. 0 degrees is less than theta is less than 90 degrees. And now if we're looking at those, so all the cosine values, what's going to be true about my cosine values? Well, cosine values are the x values. And if you look at every point here on our unit circle, all the x values here are going to be positive, which is why I have the less than 90, because otherwise you have to have the 0. So cosine values for all angles between 0 and 90 are going to be positive. If we're looking at the sine values of all the angles, actually I'm going to change this a little bit. I'm going to say cosine of theta equals a positive. If we were to look at the sine values for all those angles between 0 and 90, so the sine of all those angles, well, sine was my y values, so then the y values in there, they're all positive as well, something between 0 and 1. So all the angles between 0 degrees and 90 degrees have cosine and sine values that are positive. Well, now if we go over here to quadrant 2, if you remember it's quadrant 1 and then quadrant 2. So over in quadrant 2, what angles are we talking about? And now it's going to be 90 is less than theta, which is less than 180. And I should put the little degree symbols in there, so 90 degrees and 180 degrees. And what we're really then talking about is all the angles from like here, a little over 90, all the way around to 180. So that's the ones that we're looking at. And we could go on then and say, well, what about my cosine? So cosine of all those angles between 90 and 180. So cosine is our x values, so all the x values here of all those points on the arc on that part of the unit circle are going to be negative. And then if you were to do the sine of all those angles, well, the sine are the y values of all those points on that part of the curve, so they'll still be positive. And we could go through and finish things off. I'm maybe going to try to speed things up a little bit so I don't lose you, bore you to death. So all of our angles here in quadrant 3 are going to be between 180 degrees. Oops, 180 is less than theta, is less than 270 degrees. And now if we're doing cosine of theta, all my cosine values are still negative. And all the sine values, all the y's, are going to be negative as well. All of our y's now are below the x-axis. And the last thing then, quadrant 4, which is going to be all the angles between 270 degrees and 360 degrees. All the cosine values now. So all those angles in there, all the x values, all the cosine values will be positive. And the sine of all those angles will be negative because all the y's are negative. That's really the gist of section 5. They also have some other questions that are going to show up in some of the examples, but I'm going to move on to the other stuff. And I do give some questions on an additional sheet in my class for this other stuff. Alright, so a couple examples. We'll kind of drive the notes of these examples. So I'm saying find the x and y coordinates for a point on the unit circle. This here actually is a pretty easy question, but on the first quiz on the unit circle it messes people up every year. So give you a second to write that down. Find the x and y coordinates for a point on the unit circle. And so we're looking for that point right there. We want what's the x value and what's the y value. Now the key to that is don't overthink it. We said unit circle, if I didn't put it in the notes yesterday, I'm pretty sure I did, that on the unit circle, if you can remember this part here, that x equals the cosine of theta and y equals the sine of theta, if you can remember that, you can solve most of the questions I throw at you if you can keep those two straight. And I remembered it for a long time as though x comes before y alphabetically and c comes before s. So x gets paired up with c, those are the first two letters, and y gets paired up with s because y comes after x and s comes after c. But that worked for me. Alright, so if we're looking for this x value here, well, the x value is just the cosine of theta. So if we want this x value, x is going to equal the cosine of 112 degrees. And I'll punch that in a second. The y value over here is going to equal the sine of 112 degrees. So if I grab my graphing calculator and pop over to that, I should be able to just type in cosine of 112 and sine of 112. And be careful, make sure you round correctly. So my x value is going to be negative 0.375. So negative 0.375. And my y value 0.927. I got from punching that in. Just double check both of those a second. Negative 0.375, 0.927. I was always taught to go to 4. I kind of ran out of room. So 3 digits there, 3-4 digits should work well. That's going to be one that you'll see coming up on a quiz, something along those lines. For our next example, we want to do that same sort of thing but backwards. Now here I'm giving you the points, the coordinates, and saying find the angle. So now for this one, we want to find that angle theta. So I'd quick take a second and copy down this unit circle, put in the x and y values. And again, if you're ever stuck on a unit circle question, a good place to start is to go with your equation. So x equals cosine of theta, and maybe I'll put my y, I'll squeeze that over here. So y equals the sine of theta. And now we could put in, well, my x value is 0.4266 equals cosine of theta. And we really only should need one of these two to find the answer. If we're trying to get theta by itself, we need to get rid of cosine. So if I do inverse cosine on the right side, that'll cancel it out and just give me my theta. But then I have to do inverse cosine on the left side. So inverse cosine, so my second button, then the cosine, 0.4266. And then hit enter. And I get 64.75 degrees. So theta then, so theta will be 64.75 64.75 degrees. Alright, at that point we're done. If you wanted to go through and try it with the sine value, you could. I'm going to show that once a second, but want to point out that I changed this 0.90 to a 4.5 here, so it actually works out well. Get the exact same answer, or close to the same answer. But if you wanted to try it with the y value, then you would say, well, the y value, 0.9045, equals the sine of theta. And then from there, we want to get theta by itself, so we do inverse sine to undo my sine. Whatever you do to the right side of the equation, you have to do to the left to keep it equal. And then we could grab our calculator and do inverse sine 0.9045, and we get the same 64.7, I guess 6 with some rounding here, but essentially the same answer as the 64.75. And that's my example 2 then. For example 3, I want to show this. Now this you won't get the same answer if you do the x and the y. And that's really kind of the one I wanted to show. So if we go here and say, alright, I'm going to take my x value. X equals the cosine of theta. Well, for theta we're looking for this angle here. Sometimes what's good is to go through and kind of guesstimate. You know, this thing here we came up with 65-ish. You know, if you look at it, yeah, it's believable, 65. So for this one here, all the way around is going to be 180 if we get to this point. So we're less than that for sure, maybe 160, kind of. So if we end up with something though like 50, we know our answer is wrong. It should be more like 150, 160, something like that. All right, so my x value equals cosine of theta. So if I would put in my negative 0.9397 equals cosine of theta. I'm going to not show all my steps, but if I were to do inverse cosine of this, it would simplify down to theta. So I want to do inverse cosine of negative 0.9397. So inverse cosine negative 0.9397. And that does give us 160, pretty much right on the money. So then that makes sense. Our angle is 160 degrees. So 160 degrees. And that works. The point that I'm trying to show you in this example, though, is that it doesn't work for the y. If we would say, well, y equals sine of theta, my y is 0.342 equals sine of theta. It seems like we should be able to just plug along like before. All right, I want to do inverse sine to both sides. That would cancel out my sine. And I'll move my theta down a little bit further. So theta equals, it really seems like I should get 160 degrees again. But instead now when I punch it in, if I do inverse sine 0.342, I come up with 20 degrees, which is horribly wrong. 20 is nowhere near 160. And the question is why? That's really the point of the whole doing the notes, is why. Well, if you think, okay, well, where is 20 degrees? What's the calculator doing? Well, 20 degrees, so if we have 0 degrees, 90 degrees, 45 would be in the middle. So 20 should be a little bit less than half of that. So 20 is maybe something like this. So if right here I have my 20 degree angle, so that's 20 degrees, well, what's my calculator thinking? And if you're on the ball and you're looking at the picture, you can totally figure it out. That your calculator, when you type in inverse sine of 0.342, all it knows is that that y value is 0.342. If you're looking on your unit circle, you have 2 spots on your unit circle that have that y value. So your calculator has to decide, what does it do? What are you looking for? Are you looking for this 20 degree angle, or are you looking for this larger 160 degree angle? All it knows is that you're up that high. Your calculator by default typically is going to give you the smaller angle, because usually if you're working with triangles or something like that, you're looking at a 20 degree angle instead of 160. 20 is just way more common. So your calculator is programmed to give you that smaller angle, which then leads us up to this one here. Now, so if you have questions on this, please write it down a second, ask me in class tomorrow. Because this next section is where it's going to really get screwy. That here, neither of them work. So I'm going to start out with the y value, because later on in this chapter we're going to have to use the y a little bit more often to find our answer. But it'll work with either one. If you have y equals the sine of theta, well, all my calculator knows is that it's down this much here, that we're down negative 0.6428. So negative 0.6428 equals sine of theta. I probably should back up and make the comment, okay, now how many degrees are we looking at? So just so you know, ballpark, and then when you get your answer you can either be like, yeah, that's reasonable, or something is terribly, terribly wrong. Or between 180 and 270, looks like we're a little bit less than half. So half would be 45, or 180 plus 45, 225. So maybe let's say that our angle here, granted we're starting over here at the positive x, my angle theta should be 220, 221, 218, you know, something like that. 180 plus a little bit less than 45. Alright, so as I go through now and do my inverse sine, that would get me theta by itself, inverse sine. And I can punch that into my calculator. So if I do inverse sine, negative 0.6428, I come up with a negative 40 degrees. So going back over here then, theta equals negative 40 degrees. So somehow we have to use negative 40 to come up with what this angle here is. To do that, I'd start by saying, well, okay, what do we know about my negative 40? And I'll maybe underline this in red. If we try to take negative, well, negative means we're going around clockwise. So negative 40 should be right about, 45 would be right in the middle. So negative 40 is going to be a little bit less than that. I'm actually kind of cheating. What I'm doing is I'm taking this approach. The calculator knows it's down that far. So when we use the sign, it's saying, all right, hey, look, you're down this far. Well, what two spots on your unit circle are down that far? And that's how I drew that one in. So when your calculator does negative 40, it's saying this angle right here is negative 40 degrees. I'm going to make that in red. So this is negative 40 degrees. Well, now if this is negative 40, you can go through and figure out other angles on your unit circle. A lot of times people will jump to that this here is 50 degrees. Then they'll jump to that this here is 50 degrees. There is a way to do it all in one shot. So 50 degrees, 50 degrees. Well, if I want this blue angle, that blue angle is going to be all the way around here to 270. If I do 270 and take off this 50 degree wedge, so I get 270 degrees minus 50 degrees, I get my 220 degrees. So that's one way to come up with how many degrees we have for this theta, 220. What's going to be a little bit easier is to skip these two green 50s. You say, well, hey, look, this is 40. 40 degrees gets me down 0.6428. Well, if that's 40, kind of you throw some symmetry in there, this here has to be 40 as well. So your blue angle, you could look at that as though it's 180 degrees, add on another 40, so you could say, or theta equals 180 degrees plus 40 degrees. Either way, you come up with the same 220 degrees. I don't think I have another copy of that. I'm maybe going to go real fast and show what would have happened if we did the cosine value instead. So maybe let me get rid of these here, and I'll just drag these out of the way. If we had done the cosine instead, and get rid of those. Alright, so if we'd done the cosine in 2 minutes or less, watch, I don't think I'd write it down, but x equals the cosine of theta. So we have negative 0.7660 equals cosine of theta. And then we could do inverse cosine on both sides, and we'd have inverse cosine negative 0.766. And I come up with 140 degrees. Now you could either use this 140 degrees, or you could use what's going on with cosine. That when we do cosine, we're telling our calculator, hey look, we're looking at the x value. So what two spots on the unit circle are both this negative 0.7660 to the left? And my dash line's off a little bit there. Maybe I'll try to slide over a little bit. But it's essentially saying, hey look, we're going to give you the angle that goes as far to the left as this angle does. So when it gives me 140 degrees, it tells me that that's 140. So now, if that's 140, this has to be 140 degrees. So when you're looking for your angle here in blue, you're looking for theta. You could, if you wanted to say theta equals, well, all the way around would be 360. Take off this 140. So theta equals 360 degrees minus 140 degrees. So you get your 220 degrees. That would work. Or you could figure out this here has to be 40 and again do 180 plus 40. But the point is, if you can figure out what your calculator is giving you, put that on the unit circle, look for some symmetry, you can find your answer. Believe we're up to the last example. Yep, last example. Find another angle with the same sine value as this. So we'll whip through this one, then we will be done. So maybe start out by saying, hey, y is going to be the sine of theta every time on the unit circle. So when we're looking at same sine value, we're really saying, well, what has that same height? What has that same y, that same amount upward? And when we get that, that's going to be this angle here in black. Hits the unit circle at the exact same height as our angle here in blue. So if maybe this is theta. I guess I didn't actually write out what the value was, because I should figure out that angle to begin with. But maybe let's say it says draw another angle that has the same sine value. So then this theta here in black, maybe we'll call it theta 2, would be the same angle. If you were kind of hurt and you wanted to figure out, you could say 1, 2, 3, 4, 5. You could say the y value here is 0.5, which I'm hoping some bells go off in your head. What angle had a y value of 0.5? Going back to section 1, the properties, has to be 30 degrees. So if that's 30 degrees, this has to be 30 degrees. So my black angle here, theta 2, is going to be 180, which would have gotten me over to here. Take off the 30 degrees. So 150 degrees then is going to be the other angle that has the same sine, the same y value as 30 degrees. That's all for section 5. Hope you love the unit circle. I really like it.